They're playing against each other.
Okay, hello guys. Thanks for joining this session. Today we have Leigh with us. He's going to talk us about Rust, which is a programming language. It's really fast. It guarantees thread safety, and it's like you can use more or less the same things that you can do with C++. But I think Leigh is going to show us how amazing it is, how beautiful language compared to C++. Or maybe some people may argue that C++ is better. And Leigh actually, he's a mathematician. He graduated with honors by University of Bristol, and then he carried on going deeper in mathematics, and he did a PhD by 2012. And his thesis is about constructing self-injected great rings with a view towards the generating hypothesis. And actually, that sounds very complicated, but once he explained about it, it's really easy actually. So if you have the chance, don't hesitate to ask him. Now he's been trying to get a virtual machine and learning about how to do mathematics and apply that to programming. And therefore he ended up looking into Rust. So hello Leigh, how are you?
I'm fine, thank you, Juan. Thank you for that very nice introduction. Okay, so Rust. What is Rust? So I was going to do something a little bit different today. I think originally we were going to be talking about making some kind of model in Rust, how to do withdraw, deposit actions and transactions, transfer actions on this. But last minute, I kind of decided that the hardest thing about Rust is actually how to actually declare variables and how to do what the actual ownership model is like in Rust. So to help me last night, I wrote this lovely little commented file, which would hopefully I'm going to take you through this bit by bit. Okay, so what is Rust? You go to the Rust site. Hopefully this is going to open up here. So very easy to install. You just go to Rust, indeed the Rust computer game. It's actually just a language. Okay. Rust programming language. So it's extremely easy to install. Click install. Takes about 5 or 6 minutes, and then you're done. Creating new projects. You can use something called Cargo. So for example, if we just open up the Git bash in here. It's to make a new project as easy as cargo new my project, and you can use a flag bin, which makes it into a binary, but without the actual flag bin, it makes it into a simple library. It's pretty simple. So we've done that earlier. Okay.
Sorry. Does that cargo come with Rust? So when you install the
Rust comes with cargo.
Okay.
It's all
not like another thing to install.
No, not absolutely. So you get all of that with the installation for Rust. So earlier on I just did cargo, my new project, and I called it Lunch and Learn. And we have this open up in here. So I'm just going to see how to run.
Sorry, there is a little bit of delay with the Hangout.
Okay.
Actually, it's frozen now. Oh, now it's appearing. Yeah.
Now
it's appearing, but it's a bit slow.
Okay.
Yeah. Now, yeah, we are in the same page.
Sure. Okay. So previously I created this Lunch and Learn project, and to get it to build, you just do cargo. It's a binary, so cargo run, and it'll run my little main function here. Very simple. So probably similar to how you're kind of used to using with Elixir and that kind of stuff, or JavaScript indeed. But anyway, so from the Rust homepage, what is Rust? So Rust says it's a systems programming language, runs blazingly fast, prevents segmentation faults, and it guarantees thread safety. So system programming language, so that's the kind of language that you're going to be using to build operating systems or game engines or really server level kind of applications. Blazingly fast, comparisons to the C programming language, it's a few percentage points off being as fast as C. Guarantees thread safety, so out of the box, it's designed to be completely concurrent language. But the thing that I'm going to concentrate today is how does Rust prevent seg faults? So
What faults?
segmentation faults. So what is a segmentation fault? Okay, so essentially segmentation fault is where a program overrides or gets access to a block of memory that's in a legal way. So for example, if you have a read-only block of memory and your program decides I'm going to try and write over that read-only block of memory, or if some other process is actually using a particular block of memory and your program accidentally decides to do something with it, and it can cause some pretty horrible errors which are kind of present, especially doing a lot of programming in C or C++. So part of the Rust language in the whole has been designed, and the syntax has been designed to actually stop segmentation faults from happening. It basically guarantees that it is possible to have a segmentation fault, and that's done by this thing called an ownership model, and essentially, at least the first part of the talk, or maybe the entire part of the talk, we're going to be talking about how it does the ownership model, and this is actually one of the hardest parts of Rust, and as soon as you get over this bit, it's actually quite easy and it's quite nice and it kind of makes sense. So the first thing to note, everything in Rust is immutable. So if you actually, so for example, you can define a variable, so let I don't know, y equals 2, y equals 3. If I was to try and modify that, y equals 4, for example, it would throw an error. You can't actually modify that variable at all. It's already equal to 3. You are allowed to rebind it, so we can only let y equals 8, for example, but now this is actually pointing to a different resource entirely. But Rust does give you the option to make variables mutable by using this mutate keyword.
So the kind of word like a shady word.
That
like shame.
Almost like a shame, but it's. I think you can use it all the time. It depends if you can go with Rust. You can go either a purely functional way of programming, or you can do kind of imperative programming as well. It's where you can mutate variables. Depends what the situation is and what the context is, because in certain situations it might be better to have a mutable object if you want to do things quickly, for example. But the way it handles mutable variables is particularly nice, and also guarantees this. We don't have this thing called a segmentation fault, but yeah. So we can. So yeah. So for example, here I've made a mutable variable x equal 3, rebound it to 5, and if we run just open up the terminal again, terminal here, and cancel cargo run, and the first thing, this line here corresponds to actually what we've done. We just set it equal to 5. Very simple. And a little note about the syntax. We're doing print line. This exclamation mark is means it's a macro. And in Rust, we use macros all the time because you can write lots of code, which can be quite tedious sometimes. They can wrap it all up in a macro that kind of you use all over the place, and they're really, really helpful. This token here, this weird semicolon question mark, is basically prints out the debug version of, basically, if you want to debug the item, it basically is, imagine it's doing x.toString with this token here. Okay. So let's talk about ownership in general. Okay, so what we're going to do is we're creating a vector. We're going let v equals vector. So this again is a macro. 1, 2, 3, 4 are the elements. Okay, so Rust. So what we have here is it's just a type dynamically allocates elements on the heap at runtime. So these are kind of similar to reference types in C#. For example, so what happens behind the scenes? So we have a stack, vector gets created on the stack, and at the same time on the heap, an area of memory is allocated for those elements. So at runtime, the heap basically grows if you're adding more elements to this thing, and it's actually referenced on the stack. So we have vias on the stack, elements on the heap. Grows as that increases. So essentially, what we've done here is we defined a v equals vec at the end of the main method down here. As soon as it leaves scope, there is a garbage collection, but it's completely deterministic. As soon as it goes out of scope, the vector and all of everything related to that vector is immediately cleaned up by the garbage collector.